Talk to Me Tuesday. Last week, unfortunately, I wasn't in Trieste, so I couldn't film. And this week, I still haven't done anything. So I'm here in the 3D printing lab of ICTP, the International Center for Theoretical Physics, that is based in Trieste, and where my fiancé works. And I'll be doing a special Talk to Me Tuesday about 3D printing. I'll show you the lab, I'll show you all the different machines, all the objects that we've done here. And I think it could be something different from the normal Talk to Me Tuesday I'm doing. And so, if you're interested or curious about 3D printing, I'll try to explain everything about it. So as I was saying, this is the 3D printing laboratory of ICTP. Here you can see the sign. And here it's all the thing we should be doing, and we're way back in doing, so we'll skip off immediately. So I'll show you some of the machines. This is an Ultimaker. This came as a kit, and I've been building these ones together with other people here at ICTP. I have to say that they are more the instructions are scarier than they are, because they're not so difficult to do. You just tackle each step one at a time, and then you really manage to get from a bunch of pieces to a working machine, believe it or not. So this is what it's been printing while I was filming the Italian version of this Talk to Me Tuesday. It's a small vase. As you see, let's break down the machine in pieces. This is the base where all the objects are created, layer by layer. This is the hot end, from where the plastic is extruded and is layered on the base. Here are all the cables, and in the end of this one we've got the Rio with all the plastic. Obviously the color of the plastic corresponds to the color of the finished object. This is PLA, and it's a biodegradable plastic. And another possible plastic that is very commonly used is ABS. That's the same plastic made for the small Lego building blocks. So this is where the plastic is fed through to the hot end. And these are all the rods that move the hot end in the two directions, while the base is moved by this other rod up, down, layer by layer. Here you can see the controller. This machine in particular can be hooked to the computer, or it can be, the different designs can be put on an SD card, a normal SD card here. And on the small controller you can see the temperature. Now it's getting lower and lower because it's not printing anymore. Usually you print something like 220 degrees Celsius, obviously. And you see the percentage of the object that it's been made and how long it took. 19 minutes, it was the time for doing the small vase. They really are very slow because they have to do layer by layer, and you can speed them up or make bigger layers, but the quality will certainly be less precise afterwards. So let's see other printers. This is Polish, it's a CB printer. This is much more sturdier, made of metal. As always, here is the plastic, and we can follow it up till the hot end. Down here, there are some fans to cool down the plastic while it's extruding. And this one covered in blue tape. In this case, it's masking tape. It's the place where the object will be built up. And on the other side, we can see the kit to make another CB printer. I'm working on this one right now. I'm waiting for the guy that will help me out, and I'm filming before he comes here. And here are all the bits and pieces that hopefully, if we are good enough, will eventually become a working machine. Let's hope so. So you see there are all the step motors and all the different rods. And here is the base of the machine that we built yesterday. Here you can see the various types of plastics. These are nylons and HIPs, and there are various more difficult to find types of plastic that we are trying out for educational purposes. There are also the flexible ones and so on. Here is the PLA I was talking to you before. It comes in two different sizes. This is 3 millimeters and the other is 1.75. Different machines ask for different kinds of filament. There are various colors. And this is the ABS, the ones that I was talking to you about, the Lego bricks. And also in this case there is the 3mm or the 175. So this is a particular kind of ABS that you see changes color with the temperature. It becomes from blue a light green. I've seen some stuff done and it's really fun. It should be nice for jewelry in my opinion, because if you put it on the skin it will change color. It's really cool. There's also a gray one. Really cool. Thanks for... So here is the necklace I was talking to you about last time that made some people very curious. It's a necklace made with using 2 different softwares that you can download freely on the web. So one of these free softwares transforms the equations into surfaces. So you just feed it the equation and it will give you out a 3D object that you can manipulate on the screen. Afterwards, this equation can be then fed to a different software that is the one that transforms it to the right type of file that the printers then can work on. So this is a pseudo-duplin, I don't know how it's pronounced, and it's a mathematical surface that I know nothing about because I had the worst grade in all my college was the one in math. So I won't tell you anything about the original math function, but I can tell you about the building of this one that was made on this machine. It needed a kind of support, otherwise the machine needs a good flat surface for the first layers, otherwise the object might shift, move, and then get ruined. So there was some kind of a raft underneath and a support structure, and then the machine built it layer by layer. You can have an idea of the layers watching it on the side. You see here a little bit the layers, and this is the finished object. If the object suits you, you can then also send it to a professional printing service that can transform it in a metallic object or also a ceramic one, because they have different kinds of printers that don't use a filament but they use the powder, and so they can print with various materials like metal. So you can have your own small pendant made from your design, tried out as a prototype in plastic, and then printed also with another kind of material. Here I was showing you is the MakerBot. This is one of the most famous 3D printers, the one that started it all, at least from the normal user's point of view. And it's printing a stretchlet. It's a small bracelet. As you can see, the head, that is the one that melts the plastic, is moving through all the perimeter of the bracelet, and then everything moves down from a layer and starts all over again. Here you can see also in this one the controller. You can see the temperature, 210. You can see the other extruder, because this one can print in 2 different colors. So the first extruder, the one on the right hand side, there. The one on the right hand side is hot, while the other one is 37 degrees Celsius. That is the temperature of the room. And 65%, it's how much of the stretchlet, the name of the object, has already been done. And here you can see it moving. And here is another Ultimaker, another one that I've built. Here is the small vase that it's already been built before, and here it's starting again. You can see he's doing the layer at the bottom of it, and when he's filled all the bottom, he will start doing the perimeter of the vase all over again. And here you see again the controller. Heating is okay, it's 1% of the object, and this is slightly hotter, 220 degrees always Celsius. So I still have a couple of small printers just for the novelty of it. So here is the small printer bot Junior. This is a portable one. You can just flip the base and it becomes very small sized and it can be shoved, they say, also in a bag. I would put it in a box, but it can be easily transported. And then there's also another one of the same size. Whoopla. And this is the Porta B, and it's another small one. Also, this one came in kit and we assembled it, and most of the pieces are already made with the same plastic and they have been printed by another similar machine. The idea behind these consumer 3D printer was that they could self-replicate themselves, at least for part of the structure. Obviously not the motors, the step motors and all the pulleys and so on, but the structure could be self-replicating. And now, finally, I'll show you some bits and pieces that we've been printing in this period. So, these are the most technical ones. This is a hand, a robotic hand. There are some elastic bands for the movement, and it's hinged. And then you can see other fingers that we were trying out. This is I don't know the name in English. Helica. Here we can see some nuts and bolts that can be screwed on and off. They are perfectly working ones. With one hand it's almost impossible, but you can see they are screwing up and down. And then there's a pair of funny looking scissors that have been used for the inauguration of the lab, because the director of the ICTP center came and cut the ribbon that closed the room. Here you can see some more complex structures that were needed for the educational purposes. These are three-dimensional graphs. I've got problems with the names of this stuff, sorry about this. This has been made with two different plastics, and the one that I was showing you, the MakerBot, that has the possibility to print with two colors or two plastics. One of these is soluble, so after building the object you can just stuff it in water, and after some hours part of the plastic can dissolve. So you can have a structure that keeps the object in place while printing, and then just dissolve it without needing to take it away by hand. These are parts of a small helicopters and small airplanes. And here we can see the QR code. If you've got a camera, you can try and see if it hooks up. The QR code for the 3D printing lab, the workshop that will be held in a couple of weeks. And here there are the small vases I was showing you before when they were built, printing. And this is a Calabi-Yau structure. This is so complicated that I still have to understand how it's written. It's a 5-dimensional structure, something terribly mathematical and physics that I have no real comprehension about, but it looks cool. And behind it's a very, very nice lamp that here you can see lit up. We didn't have the right kind of light, so we used these small Christmas lights to put inside, but the effect, it's very nice. Most of the stuff was drawn by people that are very, very good at CAD drawing, CAD drawing, and 3D technical drawing, and they are doing all these kinds of objects and then putting them for free on various repositories. The most important one, the most well-known, is Thingiverse. These are real teeth and that are used by some dentists for educational purposes. You can see where the nerve is passing, and they take these ones with themselves when they go to Africa to do teaching, because they can show to the doctors there precisely where to put their tools, where the nerve is passing, and how to operate without doing any damage to the patient. And then here we've got a very cool looking lamp. This one also is made by the same guy that drawn the one I was showing you lit before. This is made with the idea of it being a plant. You can close it with your hand on top and then open it up like this. And it's all made with a single piece of... it's a single object, there's no need to assemble it afterwards. Here you can see how it's structured. This one didn't finish printing, unluckily, but you can see very well how it's working, the hinges. And so on. Various mathematical structures and small objects to try the printers. More bracelets. And here also more small objects. Vases. This is very nice. You could hang it and put a small flower inside. And this is to fix a flashlight on top of your reflex camera. This is the hot end where normally the flash is hinged. And you can just put this one on top and print it out with the right size for your flashlight, and then fix the flashlight right on top of your camera. So I think I've shown you enough. Let's see the object almost finished on the other side. And here the printer is printing another small vase. As you see, it moves up in a spiral form this time. And it's making a very translucent, very, very thin vase. And with this one I think I'll finish. Here you can see the temperature and... oh yes, thanks. So, thanks for the attention. If you've got any questions or anything, I think it's enough for this week. I've talked really a long time. And I hope you have a very nice week, and we'll see us next time. Goodbye! So I think I've talked about this time enough. So goodbye. Ciao!